Good evening, Bearcats. Okay, here we go. This is the pre-assessment for your test tomorrow. This will be your first major grade of the third 6 weeks. So juniors, stay up there because you've got to keep improving your grades so you have good college GPAs for next year to apply to college. And seniors, we've got to keep moving forward to keep your GPA, your class ranking, and to make sure that you're passing the class. So work hard, study hard, and I think you'll do just fine. All right, here we go. First one, we're going to talk about some graphing. We're going to talk about graphing. The first thing we're going to do is identify what the base function is. This is the function that we've been given, and the base function would be y equals 3 to the x power. The plus 2 would be a transformation. We want to create a table for the base function. This is exactly what I want you to do on your test. So you would have your x and your y value, and for this function we're going to use -2, -1, 0, 1, and 2. 3 to the -2 power, let's talk about that. 3 to the -2 power would be the same as 1 over 3 to the +2 power, which would be 1 over 9. And I think you get the picture there. So this would be 1/9. This would be 1/3. Anything to the 0 power is just 1. 3 to the first would be 3, and 3 squared would be 9. The next thing I want us to do is I want us to graph these base points. We want to graph these base points. So at -2 would be at 1/9. So that's just above. It's going to be kind of hard to graph on here. Oops. At -1 we're at 1/3. Again, just above the line. At 0 we're at 1. At 1 we're at 1, 2, 3. And at 2 we're at 9. So if this is 3, we're 4, 5, 6, 7, 8, 9. And it looks like those are our base points. And I do want your base points on your test, please. All right, I'm going to try to do our graph in red. I want us to graph the base points. We did that. I want us to describe in words the transformation before we move the points and draw the function. So if I'm describing the transformation, let's go back up and look at that. We have y equals, or f of x equals 3 to the x plus 2. You know that that would mean that the x plus 2 is with the x. That means it's horizontal movement. And remember, x is a little backwards, so instead of going to the right 2 where it would look like that, we would do the opposite and go to the left 2. Go to the left 2. So in our description, the only transformation we have is left 2. So we're going to take each of those points, move them left 2, and then draw in our function. So if we do that, we end up about right there. If we do that, we end up about right there. We do this, we end up about right there. We do this here and here. And our function would look something like that. All right, I didn't ask you in your review, but I do want us to talk a little bit about would be of the new function. Let's talk about the domain and the range real quick. The domain, of course, are your x values, and it looks like this graph would continue to move to the left forever and also trail upward, but also to the right forever. So our domain looks like it would be negative to positive infinity. Our range, however, looks like it's going to hit an asymptote right here. At y equals 0, so it's going to be greater than 0, so your range would be from 0 to positive infinity. All right, let's move on and answer the last question about graphing today. We're going to describe in words the transformation from the above graph. Remember, our above graph was f of x equaled 3 to the x plus 2. And we want to go from this graph to this graph, and we want to just describe the different transformations. Okay, a couple of things are a little tricky here. This 4 kind of wants to throw you off. The 4 is positive. The 3 now is negative. This 4 is not with x, so it's a vertical shift. I'm going to move it to the end of my equation. I think it'll look a little clearer to you. If you go g of x equals negative 3x plus 2, and then the 4 is positive, so plus 4. I think you'll see a little bit more what to do. All right, so we're going to notice that there are two things that are different from the original graph. The two things that are different is this negative and, of course, this plus 4. Neither one of those are with x, so both of those are vertical. Negatives always mean reflection, so if we reflect vertically, we'd be reflecting over the x-axis. So you would have f of x, the original graph, and it would be reflected over the x-axis. And then, of course, this plus 4, it would be also moved up 4. And that would be how you go from f of x to g of x. All right, let's move on. All right, next we're going to talk about compound interest. There are two interest formulas. There are actually three interest formulas. There are two that I think are particularly important for this test. The basic interest formula would be the amount is equal to the principal 1 plus the rate raised to the power of t, which is time. That's just your basic annual compound interest. So if it was just something was happening to it once a year. The two that you need to be really close and have really understand really well, and also make sure that you have committed to your memory, would be the following two. What if our interest was compounded more than once a year? So like, what if the amount equals the principal, but it was compounded more than once a year? We still have the rate, but we want to compound that rate by the number of times that it happens a year. So every time that rate happens, and so if it's monthly it would be 12, if it's quarterly it'd be 4. So we're going to put an n here for the number of times. I'm just going to make sure that's the number of times compounded. And then we would raise that to the nt power. So again, this number and this number should be the same. You would multiply those two together before you raise it to this power. Please be really careful. Practice in your calculator to make sure that you're getting the right answer. Please make sure, as instructed on your test, to write the original equation, and then show all your substitution and all of your work leading up to your answer. All right, the other one that you want to know about is if something's compounded continuously. So that's where our amount would be equal to the principal, and we would have E, because that would work for our rate of continuous, to the RT power. That would be the ratio if it was compounded continuously. So these are the two formulas that you really need to know. So just make sure that you are very comfortable and familiar with those two formulas. All right, let's see if we can work this problem. All right, if you invest $2,500, that would be your principal amount, and it's invested at 11.5% interest. Please make sure, this is one real common mistake, that every time you have a percent and you're using it in these equations, you must change it to a decimal. I'm going to cross through it immediately, and remember, you go to the left, like the Beyonce song, and you end up with 0.115 is your decimal that you will use. What is the value in the investment after 10 years? And 10 would be time. The question goes on down here is that what is the difference if the money is compounded quarterly or continuously? Compounded quarterly or continuously. So I think we need to find out what would happen if it's compounded quarterly, what the value would be if it was compounded continuously, and of course if we want the difference, our answer here is the subtraction of those two values. Well, you notice here also we're going to use 2.72 for E in our formula, because you will not have a graphing calculator. You'll only have the little blue calculators for this. All right, so let's go ahead and substitute into the first equation. So we have A equals our principal amount of $2,500 times 1 plus our rate, which we have as a decimal, 0.115. And if we're going to compound it quarterly, this would be 4. Remember, if this was monthly, it would be 12. If it were daily, it would be 365, etc. And remember, this number and this number should be the same. and it's raised to 10 years, so times 10. All right, we're going to figure that out in our calculator in a minute. We're also going to calculate it as continuous, so that would be A equals our principal 2,500. And E, and remember we're going to use 2.72 for E, and that's raised to the rate, which is 0.115 times 10. All right, so let's calculate both of these in our calculator and see what we come out with. This is the part you need to make sure that you are doing correctly, your substitution, but make sure in practice the calculator part, because I'm afraid that some of you will make a mistake in the calculator. I'm going to go over the process and then I'm going to do it and write the answer down. You won't be able to see that part. Let me see if I can pull up my calculator and let you see that, because that'd be important. Let me go ahead and go over it first, though. So what I would do is I would go 0.115 divided by 4. I would enter in my calculator. I would add 1. I would enter again. I would raise it. In this case, I know 4 times 10 is 40, so I'd raise it to the 40th power. I would enter, and then I would multiply by the 2,500. Over here, I would do 2.72. and I would raise it to, and I'd make sure I put a parentheses when I put 0.115 times 10. I would enter first, then I would multiply by the 2,500. So that's the process I would use. I'm going to push pause here and see if I can pull the calculator up just to show you that calculation. If I can't, then I'll just write the answer down and you can practice. Oh, you know what? It won't matter because it would be a graphing calculator on here, and you'll only have a blue one. So practice in your blue one to make sure you get the right answer. So I'm going to push pause for a minute and let you work on that, and then I'll get right back to you, and we'll see if we agree. All right. When I made the calculation compounded quarterly, I got $7,768.44. When I made the calculation compounded continuously, I got $7,901.22. So the difference is what we were looking for. If you subtract those two, the difference is $132.78. So if you were to be able to find a deal where you could compound something continuously over 10 years with this investment, you would make $132.78 more than if it were compounded quarterly. All right, let's move on. Okay, in the following set of problems, we're going to use the one-to-one property to solve for x. And we are actually solving for x. When we simplify, often we use x in there to replace what the simplified value would be, but there is no equal sign. If there's no equal sign, you really can't solve for anything. In this case, though, we are solving, and we can do so because each of the problems will have an equal sign. So in the first one, we are already one-to-one. The bases are already 4 and 4, so all we will need to do is solve the numerators, which would be 5x equals 4x minus 2. I would subtract the 4x on this side. I would get x is equal to negative 2, and that would be my answer. In the second one, our bases are not one-to-one, but I believe we can force that to happen. I believe we could rewrite 4 as 2 squared. That's just replacing the 4. It's still raised to the x plus 2 power. And on this side, we would have 2 to the x minus 1 power. Let's move over here. All right, so if we have a power to a power, our property says we would multiply. So we would have to do 2 times x and 2 times 2. Be careful that it gets distributed to both. So this would end up being 2 to the 2x plus 4 equals 2 to the x minus 1. Now we are one-to-one, and we could solve the exponents. 2x plus 4 equals x minus 1. I would subtract the x on this side. I would subtract the 4 on this side. And when I do, I would get x is equal to negative 5. All right, let's keep moving. A few more of these. In this case, I again need to find a one-to-one property. Notice that these are not one-to-one. The very first thing I'm going to do is I want them both to be I don't want there to be any fractions. So I'm going to move my 4 up. And when I move my 4 up, I'm going to get 4 to the negative 1 power. That replaces the 1/4. Now, it's still raised to the 3x minus 2. Be really careful. Equals, and on this side, I'm going to rewrite 64 as 4, and I believe that would be to the 3rd power. 4 times 4 is 16, and 16 times 4 would be 64. I need to make sure that I'm going to take care of this power to power over here. I have to distribute that negative to both the 3x and the negative 2. So when I do, I would get 4 to the negative 3x, and I have a negative 1 times a negative 2, so positive 2 equals 4 to the third. Now we are 1 to 1, and we may solve the exponents. So we'd have negative 3x plus 2 equals 3. I would move the 2 over, subtracting it. I would have negative 3x equals 1. Then I would divide by negative 3, and I would get x is equal to negative 1/3. Go Bearcats. All right, here's another one, very similar. You might even want to pause at this point, try this on your own, and then check your answer to see how you did. That will build your confidence and your speed for the test tomorrow. It'll make you know more about what you're supposed to do. So I would suggest pausing and then coming right back. I'll be right here waiting for you. All right, so we would move again the 7 upstairs and make it a 7 to the negative 1 power. That would replace the 1/7. It's raised to the 4x plus 5 equals, and I need to rewrite 49 as 7 squared. I would distribute the negative 1 to both, and I would end up over here with 7 to the negative 4x minus 5 equals 7 squared. Now I am 1 to 1, and I will solve the exponents. So negative 4x minus 5 equals 2. I would move the 5 to the other side by adding it to the other side. I would have negative 4x is equal to 7, and I would divide by negative 4 on both sides, and I would get x is equal to negative 7/4. Go Bearcats. All right, let's keep going. We have a couple of more problems here, and then we'll move on to our last section. All right, again, this is base E. We've talked about base E a little bit, being 2.72, but it goes on because it's an irrational number. But we're just trying to solve, and because they are both the same base, both the same base, they are already 1 to 1. So we really would just be solving the exponents again. So we would have x squared plus 5x equals negative 4. Okay, be really careful. This is a quadratic. And to solve a quadratic, you have to set equal to 0. So I would move the negative 4 over, and I would get x squared plus 5x plus 4 equals 0. I think I can probably factor to go ahead and solve my quadratic. X squared would probably, I would need an x and an x. Then I would need to multiply to positive 4 and add to positive 5. I believe that will be a positive 1 and a positive 4. And then my values for x would be x is equal to negative 1 or negative 4. And both of those would work. All right, go Bearcats. All right, the last one, again, this is where I might pause and take a look and see if you can solve this on your own, and then come back. I'll be here, and then you can check your work with mine. So I would pause right now and work this one on your own. All right, again, we're 1 to 1. So I have x squared minus 10 is equal to x plus 20. Again, I look like I'm going to be quadratic, so I need to move everything over and set equal to 0. So it is quadratic. I need to set to 0. So when I do that, I'd move the x over, and I would end up with x squared. I would keep the negative 10 on this side. I'd move the 20 over and have a negative 20, so I would have negative x, and then I would have a negative 30. So I would need to solve x squared minus x minus 30 equal to 0. I would factor again, x and x. I would need to multiply to 30, but add to negative 1. Multiply to 30, but add to negative 1. I believe 6 times 5 is 30, and if I want it to be a negative x, I need a negative 6 and a positive 5. 5 times negative 6 is negative 30. Negative 6 and a positive 5 would give me my negative 1x. So my x values in this case would be equal to positive 6 or negative 5, and that would be my values of x. So once again, go Bearcats. All right, let's move on to the last section. All right, this is we're going to simplify all of these. Remember, you really do not have any equal sign, so you can't say x equals anything, but in some cases it might be helpful in a little bit to, if we have to change a form or something, to use x. But right now we're just basically simplifying our exponents. So we're going to, in this case, we're going to first simplify the 8 over the 64. Then we're going to simplify the x squared over the x to the 7th. And we're going to simplify the y to the 6th over y to the 7th. And we're going to make a big fraction bar here to do that. You have to kind of think of all these as separate pieces. 8 over 64, I believe 8 times 8 is 64. So 8 goes into 64 8 times. So that would be 1 over 8. Remember, with exponents, we don't want any negative exponents or zero exponents. So in this case, we would take the smallest exponent, we keep the base and subtract exponents since we're dividing. Keep the base and subtract exponents. So we're going to keep an x, but we're going to subtract 2 and 7. Since 7 is the larger number, you would keep the x, or the base, in the bottom of our fraction. And you would subtract 2 from 7, and that would be 5. In the second one, you're going to keep y as a base, and since 7 again is the larger value, you're going to keep y in the bottom, and you're going to subtract 6, so that would just be to the first. So you would end up with 1 over x to the 5th y as your solution. All right, here's another one. Again, every time I gave you kind of a second problem here, you may want to pause and come back, try it on your own, and then come back and check your answers. That's up to you, but I really think that would be the best way to prepare for tomorrow. All right, I'm going to move on though. All right, so this one we're going to go 7 over 21. We're going to have x to the negative 3 over x to the 4th, and we're going to have y to the negative 5 over y to the negative 3. All right, 7 over 21. 7 goes into 21 3 times, so that's 1 over 3. Now, in this case, again, we're going to keep the base x, and since 4 is larger, we would keep that in the denominator. And we would subtract, be really careful, a negative 3. So you're going to have 4 minus negative 3, which means it's going to become plus a positive. Be really careful, so that's going to be a 7. For the y values, again, I believe negative 3 is larger than negative 5, so our y value would stay in the denominator, and you would have a negative 3 minus, negative 3 minus negative 5, again being plus a positive, and that would give us a positive 2. And that would be our final answer. Pay really close attention to those negative values. And when you're subtracting a negative, make sure that you add a positive. Remember, always when we're dividing, you subtract. When you're multiplying exponents, you will add them. All right. Speaking of multiplying, here we go. This is all power to power. All of the things inside the parentheses are raised now to the power of 5. So you're going to kind of break it apart like this. You're going to think of negative 2 to the 5th. You're going to think of x to the 5th to the 5th. You're going to think of y to the negative 3 to the 5th. And you're going to think of z to the 4th to the 5th. If you kind of think of them, you may not need to write them out like that, but you can think of them that way. That's very helpful. So a negative 2 to the 5th power. Well, a negative number to an odd amount of times will be a negative number. That's first of all. And then we take 2 to the 5th. That'd be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I believe that's going to be a negative 32. Have a calculator if you really need help with that. Then we're going to, if we power to power, we're going to multiply. Power to power is multiply. It's like a Power Ranger. You're powering up. It's getting really big. So 5 times 5 would be 25. You have a power to power here. Negative 5 would be y to the negative 15. And you have power to power here. You're multiplying, and that would be z to the 20th. Now, don't forget we said no negative exponents, so we have to take care of this term right here because it is negative. 32, negative 32 is not an exponent. There is no problem with negative 32, just with negative 15 because it's an exponent. So your final answer here would be negative 32, x to the 25th, z to the 20th, and we would move y downstairs and make that to a positive 15. And that would be your final answer. Go Bearcats. All right, let's do this one more time. Again, this may be where you want to pause and try it yourself and then check your answer. I think that would be really smart on your part. All right, so we would do negative 3 to the 4th power. We would do x squared to the 4th power. We would do y to the 0 to the 4th power. And we would do z to the negative 3 to the 4th power. All right, so a negative number raised a even amount of times would make it a positive. So that's really, really important. So 3 times 3 is 9, times 3 is 27, and 27 times 3, I believe, is going to give us 81. And there'd be a positive 81 this time. And then we would, again, power to power, so we're multiplying, so we would get x to the 8th. Okay, we would get y to the 0. 0 times 4 is 0. And we would get z to the negative 3 times 4 would be negative 12. Okay, this time we have two problems. We have a negative exponent, this negative 12, and we have a 0. We don't want any zeros. This becomes 1. So if this becomes 1, 1 times 81 is just 81. X to the 8th would stay at the top. And of course, z would need to move to the bottom so that 12, our exponent, could become positive. So that would be z to the positive 12. Really important problem, and that you understand all of these exponents. All right, let's look at the next couple. All right, in this case, we have a negative exponent. If we have a negative exponent, and we have a fraction, we're actually going to invert our fraction because these exponents apply to both of these values inside the parentheses. So we can take the whole fraction and make it 36 over 9, and now this becomes a positive 1/2, not a negative 1/2. Please understand that that is 36 to the 1/2 power, and it's 9 to the 1/2 power. The other important thing you need to understand that the 1/2 power is the same as the square root. So that would be the square root of 36 over the square root of 9. Now you may get confused here and think that you added in a square root. We're not solving anything, so you did not add the square root into the problem. 1/2 is just another form of the square root. So you didn't really, even though it appears you may have drawn it in, it was really in the problem just in a different form. So don't put any plus or minuses in this case. The square root of 36 would be 6, and the square root of 9 would be 3. And looky here, 6 over 3 actually would reduce to 2, and 2 would be your final answer. Go Bearcats. All right, here's another one you can try. Again, this might be something you pause and try on your own and then go back and look at. So I'll be here waiting if you do that. All right, we're going to go on. We would, again, invert our fraction and make it 8 over 27 to the positive 1/3, which is the same as 8 to the 1/3 over 27 to the 1/3. The 1/3 power is the same as the cube root of 8. So it would be the cube root of 8 over the cube root of 27. The cube root of 8, hopefully you know that, would be a number multiplied times itself 3 times, and in this case that would be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 2 would be the cube root of 8. And the cube root of 27, I believe, is 3. 3 times 3 is 9, times 3 is 27. So the cube root of 27 is 3, and 2/3 would be our final answer. Now, we're simplifying, so please realize that these are all simplified. It's not x equals anything, so we just simplified the term that we've been given. So we've just simplified it. All right, here we go. Again, I see this negative exponent, and by now you know what to do to invert your fraction. Be really careful. You do not change sign. Just flip it. Do not change the sign. You're going to change the sign of the exponent. Exponent changes sign. Okay, so we would have a negative 3 to the positive 3 power. Be really, really, really careful of that. And in this case, we're not going to invert this because this is a positive exponent. So we're going to put this over 1. And we're going to make this 1 over 4 squared. Now, to do that, we're going to have a negative 3 to the 3rd power. Negative 3 times a negative 3 times a negative 3 will be a negative 27. I'm just putting it over 1 just because of the fractions. This 2 applies to the top and the bottom. So this is like 1 squared, which is 1, and 4 squared, which would be 16. And you would multiply straight across. You would have negative 27 over positive 16, or negative 27 sixteenths. I don't believe we can reduce that, so I believe that would be our final answer. All right, let's move on. Just a little more to go. All right, same type of thing here. Again, it would be wise for you to pause and then go back and check your answer to make sure that you're fully understanding. Again, do not change this value, only change this one. Change sign. Do not change sign. So this would become a negative 7 to the positive 2 power. This doesn't change because this is a positive exponent. So this is, I'm going to put this over 1 just because it's a fraction. And this is going to become negative, and I'm going to move that negative up with the 1. It won't matter, but the negative has to either go with the 1 or the 6. Can't go with both. So we'll just make a negative 1 over 6, and it's cubed. So we have negative 7 squared. A negative times a negative will be a positive 49 over 1. Over here, we're going to apply the 3 to both. So a negative 1 cubed would be negative 1. 6 cubed, okay, because remember, you can't do both. You're not going to make both are negative. 6 cubed would be 6 times 6 times 6. I believe that's like 216. You would have a calculator to find that out. So that would be 216. And then you'd multiply straight across. 49 times negative 1 is negative 49 over 216. And then you probably could figure out if that would reduce. And I don't think in this case it does reduce, so we would have negative 49 over 216 as our final answer. All right, again, we're going to use one-to-one property, but we're not solving anything in these problems. Please, please, please pay attention to that. There are no equal sign anywhere. There are no equal signs anywhere, so please don't try to solve for x. You can't. There is no equality here. Please recognize in these next two problems, and you had one in your other review that we worked on before the break, that we have the same base, and therefore we're going to add, and we're multiplying. So if we have the same base and we're multiplying, then we're going to add the exponents. Keep the base, add the exponents. So the base we're going to keep is 4, and we're going to add 2x plus 3, and we're going to add to that x minus 1. Please be really careful of this problem. Again, I don't want you to miss this. This is not that difficult. You just have to know your properties. So you would keep the 4. You have a 2x and an x, so that would be a 3x. And you have a 3 and a negative 1, that's a positive 2. And that would be your final answer. Okay, that would be your final answer. That would be the simplified version of this original. All right, here again, here's another one. The base is b. We're multiplying. You would add exponents. Why don't you push pause, do that one on your own, check to see how you did. All right, if you did that, you should check it out, and b would equal x minus 3 plus, or not b would equal, but b would be the base. That would be the base would be b, and it would be raised to the power of x minus 3 plus 2x plus 4. So your final simplified version would be b, and you have an x and a 2x, that's 3x, and you have a negative 3 and a positive 4, so plus 1. That would be your final answer. All right, let's get on to the last few problems that we have here. We're getting toward the end. All right, let's take a look at all of these. This is kind of important. We're changing forms a little bit from exponential to radical form just to see everything. Please remember when we do this, at the bottom of the fraction, if it's raised to a fraction, the bottom becomes the root. And so in this case, we would have the cube root of negative 27, and once we found that value, we could square it. And that's how I would do it. You could square the negative 27 first, but then you end up with really large numbers, and I believe that's a little harder to work with than the smaller numbers. We can take a cube root of a negative number, that is just fine. We cannot take a square root of a regular number, but a cube root is okay because we would have a negative 3 times a negative 3, which is positive 9, but times a negative 3 would give us negative 27. So negative 3 would be the cube root of negative 27. So we would have negative 3 as the cube root of negative 27. That's that part. We would still need to square it. When we square negative 3, it's going to become positive. So negative 3 times negative 3 would be a positive 9, and 9 would be your simplified version. All right, let's try another one. This would be the square root, since the bottom is 2, and it'd be just to the first power. So this would be the square root, which you don't really need to write, of negative 16, and it would be raised to the first power. Oh, you should get a very uncomfortable feeling about now. We can't take a square root of a negative number, so we would have no solution here. Ooh, make sure you pay attention to that one. All right, let's go into the next one. Again, 3 would become our root, and 5 would become our exponent, and so we would have the third root of negative 8, and then we would raise that to the 5th power. So let's do the third root of negative 8 first. Would be negative 2. So negative 2 times negative 2 is positive 4, but times negative 2 again would be negative 8. So negative 2 to the 5th power. Now, a negative number raised an odd amount of times is going to give us a negative output. Please be really careful about that. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And our final answer would be negative 32. All right, last 3 problems and then we're done. Be careful about this negative that's on the outside. That negative applies after the fact. And let me just also warn you about something else while I'm thinking about this. The same would be true. Now, I should have written this equation. Matter of fact, at the end, remind me, I'm going to give you just another example that's important. All right, so ignore this negative for a minute. It's on the outside. So inside, we have the cube root of negative 8. And we're going to raise that to the 4th power. And then remember, on the outside, we have this negative. So look on the inside first. So keep this negative. And then on the cube root of negative 8 is negative 2. We just talked about that. And we're going to raise that to the 4th power. Be really careful. A negative number to the 4th power to an even amount of times would be positive. But this negative stays. So we have a negative, and then this would be 2 times 2 is 4, times 2 is 8, times 2 is 16. This would be positive 16. But that negative applies at the end, so your final answer here would be negative 16. Really important. Be careful about those negatives and double negatives. I'm going to give you another example here. I'm going to write it down, and we'll do it at the end. Okay, we'll talk about that one in just a minute. I'm also going to do okay, we'll talk about both those in just a second. All right, let's go on to this. This is also a double negative, so be careful this goes applied at the end. So we're going to have the cube root of negative 27, and of course that's just raised to the 1st power. Don't forget in a minute to put this negative. The cube root of negative 27 would be negative 3. And to the 1st power is negative 3. But be careful, we need to add this negative in front. And a negative negative will create a positive 3. Again, these are really important that you pay attention to these and really understand your negatives. Finally, P's pretty easy. Anything, it doesn't matter if it's negative, positive, anything to the 0 power would be 1. Okay, would be 1. Now, let's talk about these last 2 little problems down here just as a little side note. This negative, because it's not inside the parentheses, applies at the end, even though I know up there were parentheses. Because this is a positive 8, there's no parentheses around it. But this is just a positive 8, and this negative gets applied at the end of the problem. So ignore it till the end. So you would have the cube root of 8 to the 4th power. This negative would keep coming down. So the cube root of 8 would be 2 to the 4th power. And 2 to the 4th power, I believe, is going to be 16. And so this would be 16. but this would be the negative at the end, so this is negative 16. Please make sure you realize that that negative is not attached to the 8. It's at the end unless it's inside a parentheses. The same thing here, and let's take a look at this one. So this negative would get applied at the end. So right now you have the square root. We can't do that. Let's do this. Let's change this. 5 and... well, let's leave the 3. Let's leave the 3. And let's just change this to a 4. Something easier. Alright, so the square root of 4, and then we're going to raise it to the 3rd power. But that negative is going to stay at the end. The square root of 4 would be 2 to the 3rd power. 2 to the 3rd power would be 8, and then that negative would come in at the end, making it a negative 8. So please be really, 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 really careful about that. If you have a negative on the outside and nothing in here, you know the final answer will be negative. If you have double negatives, it can be positive or negative. So just pay careful attention. Okay, hope that helped. Hope you study hard. I would go back and work all those problems on my own to make sure you're really comfortable. And I will see you tomorrow for your test. Go Bearcats!